The the four-component instructional design model provides us with a potential model for doing vocational education. The four-component instructional design model draws on the cognitive score, which uses certain key concepts. The first key concept is the notion of a cognitive schema, or what they call mental maps, because their argument is that how does one get knowledge to move from your working memory or your short-term memory into your long-term memory. And the way that they argue that happens is that students have to develop, or anybody has to develop, cognitive schema. The second element that they look at is cognitive overload. They argue that your short-term memory, or your working memory, can only take a certain limited amount of input. So we should take care not to overload people cognitively during those short-term memories until they can develop cognitive schema so they can go into your long-term memory. And the third element of what they're speaking about is automaticity, is that their argument is that knowledge then needs to become automatic so that you don't need to use it all the time. For example, when it comes to your times tables, if you have to think about the timetable every time and it's not automatic, then you're using up space in your working memory, which you could have been using to develop cognitive schema instead. So by making certain things automatic through practice, for example, you can develop automaticity. So let us look at component 1 of 4. The first component and the organizing principle for the four-component instructional design is the notion of a learning task. A learning task is a complete task, and the strategy that Merrienboer uses is to start with the simple and then to make the task more and more complex as it goes along. So you're moving from the simple to the complex. And in order to do that, he provides all those different techniques like sequencing, fidelity, etc. The second element of 4, which we will look at, is procedural information. And procedural information has to do with those how-to instructions. So normally these would be the demonstrations that you would do with your students. And demonstrations are accompanied often by collective feedback. The trick here is normally to focus your students' attention on what you are doing, and so that their attention is not split so that it's somewhere else. And Merrienboer will provide you with some techniques of doing that, which you can apply to your subject. The third of 4 components that Merrienboer looks at is the notion of supportive information. The third of 4 elements that Merrienboer looks at is the notion of supportive information. And here, instead of corrective information as you have with the procedural way of giving demonstration, here you are giving cognitive feedback. So it's about students understanding cognitively, intellectually, and theoretically what they want to do. It's about students developing abstract theoretical models and systematic approaches to problem solving using the theory. This is where theory and practice comes together. And Merrienboer again provides a number of different techniques by which to do that. Yes. Finally, the fourth component of Merrienboer's work, the final component, is part of task practice. Now that the students have an idea of where what they are learning fits into the model, which is a learning task, of how to do it, which is a procedural task, which has corrective feedback, and of why they are doing it, which is your cognitive model and supportive information, which arrives just in time. Now they have to develop automaticity, which is what we discussed earlier on. And so students have to develop practice items, which will enable things to enter both into the mental map, that it is the support information, and arrive at automaticity. And Merrienboer provides a mechanism by which to do that. Now, having had this discussion, we will now enter into discussion of each of these different techniques that Merrienboer provides individually. So let's start by looking at learning tasks, which is the first of the four components. And you'll see that it gives they give a number of different ways of doing this. As you'll remember, the whole principle of learning tasks is moved from the simple to the more complex. So in many ways you make issues the model more complex by adding more components as you go along. And there are different ways to do this, which are given there. So let's just look at one of them, for example. So let's look at sequencing. Sequencing, for example, is that for physics students, and you can substitute your own subject in there, or learn to troubleshoot electrical circuits, and again you can put in your own subject there. Here's the idea that you sequence it. You start with circuits which only have a very few elements, for example just a lamp, battery and a switch, and then you continue with circuits that are increasingly have more elements. In other words, you make the task more and more complex by adding things to the basic model as they go along. And in that way, they are trying not to cognitively overload your student by adding elements as you go along. The same would go for fidelity. Fidelity means trueness. So with medical students, you'll start with historical case descriptions, which is not real. Then you go to simulated patients, and then you'll move on to real patients. So as you go along, things are getting more and more and more real as you progress and as you offer more exercises. So what you need to do in your case is you need to, for each of these 6, think about how you'd be able to use the strategy to teach something within your own subject. So there are 6 different ways in which you can organize your learning tasks, moving from simple to complex. Moving on to procedural information. So with procedural information, what you are doing is you are demonstrating how to perform a particular task. You are giving people how to instructions. And generally the rule is that the instructions should arrive just in time. So you wouldn't tell people about how to do something before the time. You provide them with instructions just as they need it, because you don't want to have a split between when the instructions are provided and when the students have to actually execute it. And so Merrienboer again gives a number of different ways in which this can happen. And remember here, what you want to do is you want to provide the how-to instructions, give the demonstrations, allow them to go through the demonstrations and provide the information. So normally they have a little sheet next to them or something like that to tell them how to in case they need to refer to that, and then you will give them corrective feedback. So this is oftentimes what many people think of as the skills component, showing people how to do something. And as you were saying earlier, what this would involve is there are a number of different things that people can do. So for example, what I said just now, for students who are working design, when they need to implement a particular aspect of the design, then you will provide them with information, not beforehand. Because remember, the main thing that you want to do with procedural information is you don't want people's attention to be split. So if there's a split between when they do the task, then they will still be spending cognitive memory, cognitive overload by trying to remember what did I do back then. You want to bring what they are learning as close to what they have to do as possible, so they don't have to make that cognitive memory and they can simply focus on doing the task at hand. Same with the spatial split. You don't want things to be split, so if you want people to know that you are doing something, they must be able to see you and see the thing in the same space, so they're not looking there and then they're looking over there. What they see must be what you are speaking about at the same time, so that you're not splitting their attention. Signaling, for example, if you're doing something, here's an example of signaling, right? You need to be showing and focusing people's attention on what it is that they need to be looking at. So for example, you need to shine a spotlight on the parts that need to be removed if you're doing a particular car. Because the car is complex, you need for them to focus on the part. So when you're focusing on the part, you shine the spotlight on that part so they can see what is happening. And so on. You can look at the rest yourselves. Of the four components is about supportive information. So whereas the previous information looked at providing learning tasks and moving from simple to complex, the second one focused on not splitting people's attention. This one focuses on students developing systematic approaches to problem solving. Right? So they must be able to use techniques in order to solve problems. And here, it's not on corrective feedback, it's on cognitive feedback. It's on helping students to develop their mental models, to develop their mental maps. And developing more abstract forms of thinking about stuff. This supports the whole notion of innovation. And again, there are three different techniques of looking at that, which we'll look at in turn. Generally, supportive information is supported by reference work. So rather than how-to manuals that arrive just in time, supportive information will have reference works which are always available. For example, textbooks. The students should be able to use this in order to understand what is happening whenever they have to do a learning task. And here are some of the techniques: redundancy, self-explanation, and self-pacing. So, to give you some of those ideas, so when it comes to redundancy, what would happen in redundancy is that you start with a qualitative model. So oftentimes people want, or students want to move from their own experience. So they will then use qualitative models to predict if there'd be any growth, etc., based on their own experience, based on their own opinion. But what you want to do then is to give them an abstract understanding so they have an all-encompassing model, like a mathematical formula. So they should be able to represent, for example, a particular problem mathematically, and then be able to apply the formula not just to that particular example or those examples, but to all examples always. And so what you then would do in the case of economic metric students is you then provide an all-encompassing quantitative model, and then the qualitative model then becomes redundant. So you're moving from the concrete to the abstract, from the opinion to the generalized abstract idea. Other examples of developing cognitive understanding is self-explanation, where medical students will find different ways of explaining that, for example, through animations. But in the animations, you will provide prompts so students are not only see what is happening, but they are provided with an opportunity where they have to then explain what is happening. So remember we were saying earlier on that the vocational education is not just about people doing, it's about people doing and being able to say what they're doing, being able to explain what they are doing and how they're doing it, and so on and so forth. You can have a look at the other models. And last but not least, part task practice, which is about developing automaticity. This is about drill and practice. One way of doing drill and practice is to turn it into a game, but sometimes people just have to do drill, like doing something over and over and over again until they get it right, until it becomes automatic so that they don't have to think about it anymore. That's the thing. They shouldn't have to think about it anymore. It should come automatically. And component fluency is for it. My dad, for example, when it comes to addition, used to make us add up cars number plates. Him and my mom used to often, just shoot us 5 times 7, so to remember our multiplication timetables. And so after a while it became, I know, 7 times 8 is 56, without even having to think about it. So those are some of the things that you have to do in order to get students automatic. And they propose component fluency as a possible way, and they use, for example, aircraft control, where students just have to recognize by just flashing up on screens different situations and say, what is this, what is this, what is this, and they must be able to just rattle it off very quickly.